Thank you, everybody. This is Lynn Rubenstein with the Northeast Recycling Council. I'm delighted that you're here, and Jean is going to be our speaker, and she's going to go to view full screen in a second. So she's taking up the whole screen. But thank you so much for joining us today. My name is Lynn Rubenstein, and I'm the Executive Director of the Northeast Recycling Council, also known as NERC. We are co-hosting this webinar with NMOA, the Northeast Waste Management Officials Association, and we're grateful for that. In a few moments, I'll introduce our presenter, Jean Bonhatal, but first I want to explain to you how you'll be able to ask questions, which we certainly want you to do. So on the upper right-hand side of your screen, you've probably got a little rectangular box with an arrow, and you click on that, and it opens the dashboard. And towards the bottom, there's an area that says questions, and you type in your question and hit return, and we'll be monitoring those. And when we get to the end of Jean's presentation, then we'll take questions, and that will work out well. I also really want to thank everybody for registering, thanks to the joy of GoToWebinar being hacked. So thank you so much. We are going to be hearing from Jean. And Terry, I can't see it. Are you seeing Jean's presentation?
Jean, I'm seeing your presentation, but you need to go to full screen. So you need to, I think, to click on the little box at the top of your slides. But you can't
did.
Top right.
I have that. I've got full screen on mine. Sharing main screen, it says. Should I click on that one?
Don't know.
I don't know.
Yeah, sorry about this.
So go to the far upper right corner, and there's that little square box instead of the X, and hit that and see if that does anything. So, everybody, we are recording this, and I'd like to introduce our speaker, Jean Bonhatal. Jean has worked at the Cornell Waste Management Institute in solid waste education for over 20 years, first working for the Cornell Cooperative Extension in Broome County, New York, then for Cornell Waste Management Institute. Currently, her time includes work on food scrap, manure and carcass, and butcher waste composting education and research, as well as compost quality and consistency in the marketplace, and encouraging the use to build healthy soils and redistribute nutrients. Previous experience includes working with different agencies, including the United States Forest and National Park Service, US EPA, the New York State Department of Environmental Conservation, and landscape and greenhouse industry. She received an MS in Education and Communication from SUNY Binghamton, an MS in Biology from Utah State University, and an AAS in Natural Resources from SUNY Morrisville. And with that, I'm going to turn it over to Jean. Everybody is on mute, and except hopefully for Jean. And Jean, It's your turn. Take it away.
Do I have the slides? Can everybody see the slides? Can everyone see the slides?
I can see your slides, Jean. So go ahead. They look good.
So I just go ahead. Thank you. Okay.
Just advance them as normal.
Will do. Thanks, everybody. Sorry for the technical difficulties. I'm on the road, but there's always technical difficulties. Okay. I'm not advancing, so if somebody can advance.
Jean, this is Terry. Your cursor has to be on the slide to advance, and there's often a slight delay when you first start advancing.
I've got it. I got it. I've never done it that way. Thank you.
Okay,
so we're going to talk about, for the next hour or so, we're going to talk about using compost in a lot of different ways. We use it to build soils, to reduce erosion, to improve moisture retention, soil moisture retention. it's important, and we'll go through some of these things. I don't need to read this to you right now, but we'll look at the natural cycles. We'll look at best management practices, using socks and blankets, how we can find good organic matter quality and what quality matters where, because we can use different quality materials in different situations and different types of materials in different situations. There we go. So the effects of erosion, I think people know these pretty well. We see them in our everyday lives. These are not pictures from the U.S. These are pictures from other places, but we have plenty of these. And that top left corner is off of Puerto Rico at the mouth of a river where all the soil has just simply washed out into the ocean. And it's just, it was an amazing picture, so I just had to capture it, and use that for some of the erosion. The steep slopes, all that, we need to work with that kind of stuff. More erosion. This is in a ski resort where they were expanding areas. I just took these last summer. We were expanding areas, and there was no erosion control berms, blankets, socks. There was just nothing to keep the silt from going down into, in this case, it was the Rio Grande. Ultimately, it was going to get to the Rio Grande. And you can see where the buildings are and where all the sand, soil, all the soil is washing out. And I'll just go through a few more. Nothing to stop things from moving, no fencing, which doesn't always work that well either, but just nothing to keep that soil in place, and it was just moving. As you can see, some of this is just that ski area, and I just took advantage of the good pictures, or the good negative example of what was being done. There is some straw that was laid down to grow some grass, but that's on a relatively flat area off to the side. And this was the Rio Grande. So and people were rafting in this, which was, it was interesting. I put my foot in there and I pulled it out very quickly because there was a lot of things alive on it. But that was the Rio Grande. So why? One of the reasons why we want to be doing this. So organic material. Why use organic material versus fences versus hay bales versus lighter materials, straw and things like that? Moisture holding capacity is tremendous. And I'll digress just slightly, but with the hotter climates that we're experiencing, the hotter and the colder climates that we're experiencing, and experiencing more droughts, even on roadsides, on lawns, in field crops. If we can increase the organic material in our soils, we will be able to help that situation. We'll be able to keep the moisture in those soils that we so desperately need at certain times, especially when we're going through some of the extremes that we deal with. So I think that's like number one in why we should be using compost in general, why we should be using more organic matter in our soil systems in general. Nutrients. The organic matter is pretty low in nutrients that we're using in all of these. So I've had some concerns from different DOTs about the different qualities of compost, and can we be using biosolids compost, which is a human manure? Can we be using even dairy manure or poultry manure composts in some places because they have higher nutrients, and some of those nutrients could leach out a little bit more frequently. So choosing the nutrient quality is important, and sometimes we'll go for a low nutrient compost. The nutrients are helpful and they're not high nutrients, but sometimes we'll go for a lower nutrient compost just to be sure. And those lower nutrient composts would be from feedstocks, and feedstocks are just simply the ingredients that we use in a compost or alone. Feedstocks that would be lower nutrients would be things like leaves and wood chips and maybe just straw, hay. Things like that are very low nutrient because they're very carbonaceous and just don't have that much nutrient in them. So if we're worried about using things over a stream, that's what we would think about that more. Long-term effects. The use of any organic matter in a soil system, the organic matter has long-term effects. It doesn't, especially if we can add enough. Sometimes we just sprinkle a little bit in and we get some nutrients out of that. We get a little bit as a start, but the long-term effects from adding a half-inch, quarter-inch of compost, of a compost medium on a roadside or a lawn or in the form of a blanket or something will be helpful. I'm talking a lot right now without a lot of pictures, but I have a lot of pictures of the actual use of all these things. I just wanted to go through some of this so that we have a good idea. Just erosion control in general, the organic matter is very important. One thing about use of organic matter, of actually the organic matter itself, a compost or something like that. When a compost, and we've had this situation happen before, when a compost windrow gets into a flood situation, it slowly sucks up all that moisture. It sucks. It's like a sponge and sucks up moisture. When it's sucking up the moisture, it stays right in place. So you can have a river going around, a stream going around out of its banks around a compost windrow. And what will happen is the water will just keep rising. And when that water goes away, the windrow will still be in place. And we've seen this a number of times. And that's the reason that happens is because that compost is that sponge and it becomes very heavy. And you'll see your 100-pound, 200-pound boulder rolling down the river and different things going down the river. You won't see the compost generally go down the river because of this situation, because it's that sponge that holds it on and then slowly releases it after the water goes away. It covers bare soil. Bare soil should always be covered either with vegetation or with organic matter. And it improves tilth. It just adds to the nutrient. It adds that whole microbiome. It improves the microbiome of the soil, and it helps with, disease issues, with pest problems, with all of that, because there's just more competition there. This is on Governor's Island in New York City. New York City is doing a lot of composting right now. So I'm just going to take you through some different compost facilities, but they're doing a whole lot of composting of New York City's food waste. As people probably know or have heard, New York City has a food waste ban in place. So that's why a lot of this is happening, and this happens to be on an occurring on an underutilized island in New York City. So, but they have windrow composts here. They're producing a pretty diverse feedstock compost. We need to know what the compost is. So we should, when we're choosing different composts, we need to know what we're choosing. And so knowing what the analysis is of that compost is helpful so that we are in the right target ranges for using some of these. And this is just an example of, what's the organic matter in this, what's the organic matter in this, what's the moisture content, what's the nitrogen, all of those kinds of things. So there's a lot of different things that are looked for, and we don't generally expect people to look for all of these analytes, because it would be very expensive for people to be able to do that. So we tend to do a lot of testing and look at the feedstocks to see what that compost is going to look like. We have a database on Cornell Waste Management Institute's website, Cornell's Waste Management Institute's website, so that you can compare and see what the analysis should be for those different feedstocks. And we should always know the crop requirement or the soil requirement. And on roadsides and ditches and things like that, we want really low nutrients. And thus I was talking about the low nutrient composts or low nutrient medium that we might use in a sock or use as part of a blanket. Organic material. Can you have too much organic material? Yeah, we can use too much organic material. It's hard. It's pretty hard to put too much on slopes, roadsides, crops, all that kind of stuff. But we have seen situations where we are turning into something more like a bog than the soils that we would like to see. pH is important depending on what we're growing, and just know what that specific crop needs. If we're growing grapes, if we're growing grass, if we're growing wildflowers, if we're growing pollinator species, things like that, we want to have a good idea of what we're using. Okay. So I'm going to go a little bit, I'm going to go through some different composts just so we have an idea of what we're looking at. Manures are high in organic matter, generally, not always, so that's something that we do test. Low in contaminants. There's not that much contamination in them in a manure compost, except for possibly copper. Copper sulfate is used in dairies and can end up in the manure stream and can be in the compost in the end. There's very little garbage in them. Needles and things like that are not in manure compost anymore. People are work hard to get those out of the compost and don't just dump them in the manure pits. Can be high in phosphorus, so we have to think about that. And if we're on a flat area, that's fine. But if we're on a sloped area and we have high phosphorus, that phosphorus is some of it is going to run over land. And for the pharmaceuticals, they're generally low in pharmaceuticals. In New York State and in the U.S., in New York State, I'll talk about that. We have a lot of compost facilities that have wood chips and compost and leaf mulch and different products that are available. In New York, we've mapped all of ours so that it's easy for people to find them. The materials, some of the materials are coming from colleges and universities, farms, prisons, DOTs, Departments of Corrections, DOTs. So different people are making different materials. Municipalities are probably our largest, and there are a lot of municipalities that are making compost. On the U.S. Compost Council website, there's a version of this called Find a Composter, and they will have all of those types of materials as well in case people need to find places. But it's something that you don't want to move great distances unless you need something very, very specific, like, okay, I need a poultry manure compost for this specific reason, and then we'll do that. So you can see, just the differences in the soil in this picture. Before compost additions, it's very clay, very clumpy, and after compost additions, it's just a better medium. There are clumps in there, and that will add to the aggregate stability in those soils, so that the soils won't just run down the slope. Okay, that one we'll have to. So I'm going to go through a whole lot of examples of places that was used, that compost is being used. This is going to be a place where it's been done wrong. So I'm using this example because it was just such a good wrong example that we had to document it. These slides are taken through glass, so there is a little bit of reflection. So I'll apologize for that, but that was the only way to get those shots. This is in an atrium area, and a firm was brought in to put this together. They knew what they were doing, supposedly. But what ended up happening was they went in there to reshape this atrium area, and they scraped down, took some of the topsoil off, and then put a layer of compost down, and then they put topsoil on top of that. And what they needed to do with that was to just put the compost down on the soil and then plant into it. If they needed to do some agitation, some tilling, some other things to mix that compost in, they could have. But in this situation, that wasn't something they needed to do. So as you can see, the soil, what happens when water drops on soil is that water wets the soil, and it makes it into a mud, and then that mud starts flowing. And that's what happened here. And if you remember my description of why those compost piles stayed in place, or the compost blankets stay in place, the compost blanket absorbs those water droplets, and it has cushion, so it doesn't pick up, and it just absorbs like that sponge, and doesn't pick it up and let it run away. In this case, that topsoil that was put on top of that layer, it was sandwiched incorrectly, and the topsoil that was put on top of that just allowed everything to just run right down and have to be re-landscaped. I'm assuming that people will tell me if there are questions. Somebody will tell me if there's a question that should be answered.
Jean, this is Lynn. So there are several questions. Do you want to take them while we go, or did you want to wait?
Absolutely. Absolutely.
Okay. So somebody asked, what is the maximum recommended organic material for roadside applications, and why should it be low nutrient?
What's the maximum application? It really depends. So it depends on, everybody can hear that, right?
Yes.
Okay. It really depends on the situation, whether we're putting a blanket in or whether we're putting this is in the picture that you're looking at right now is a flat area. And I'll tell you what they did here because I didn't think it would work. This is actually roadkill composted roadkill that was used on a roadside in New Paltz, New York. We had made all the compost and they brought it out to this area that needed to be vegetated. And they ended up putting 3 inches of compost down. Now that's a really, really thick blanket of compost. I wasn't recommending that they do that, but they decided that's what they were doing. But after doing that, then they put a track machine on it. And then they hydroseeded it. And it actually worked out. I'll switch slides. In about 5 months, and this was in November that they did it. And about 5 months later, this is what it looked like. And so it had started, the grass came up. I was feared that we would winter kill the grass seed. But we ended up with grass very, very well. And this ended up being a beautiful demonstration.
So Jean, why did you think it wasn't going to work?
Because 3 inches of compost is a lot of compost. That's a really thick blanket.
Okay.
We did a lot of testing with grass, not establishing grass, but with top dressing grass, especially playing fields and parks and things like that. And in those, we did 1/2 inch, 1/4 inch. And we could have put a full inch on, but at some point you're going to smother the grass that's there. And I worry about the volatile organic acids just being too much because the grass seed does want some soil. And the soil is down below the compost. It's not mixed into the compost.
Okay, great.
So that's why I was nervous about the 3 inches.
Yeah, okay. So somebody else asked, how much extra does it cost to do this, to apply compost on roadway shoulders?
You're bringing other things out anyway. So one of the things that we weren't doing with this one. This one was as I said, it was roadkill compost. So there were some bones in it. You can see some stuff where there might be some bones showing through there. In this one, we really can't. But in that one, after it rained and stuff, we could see some bones showing through. In this one, they scooped it up and they brought it out in dump trucks, and then they took that track machine and they pushed it around. So it was really close. So it wouldn't have cost them too much except for the fuel and the labor to get this out to this site. Okay. So every situation is going to be different. If you haul it a long way, you're going to pay a lot of money for any whether it's rock or soil or topsoil or compost or wood chips. It's the trucking that is the expense.
Great. So we have several questions about testing and nutrient loads. Should we hold those, or do you want me to raise those now?
No, let's do it. Go ahead.
Okay.
I'm happy with this being an interactive because then
great.
People won't forget their questions.
Okay. Well, they're writing them down, so there you go. Okay. Do you test for herbicides and pesticides in manure or other composts?
The herbicide that we're having problems with right now, we do. We're fortunate in that we do a lot of testing of composts. And New York State DEC allows us to test like 10 samples a year. We do triplicates. We do very thorough composting, or very, very thorough testing when we do that. And that's what has developed a part of our database, is some of the stuff that they've paid for to see what was happening, and a lot that we paid for with other grants and stuff like that. So, I think I've gotten off topic here. Lynn, remind me.
So the simple part of the question was, do you test for herbicides and pesticides? And so your answer was yes.
We do a certain amount, and the one that is the problem herbicide that we're having right now is chlorpyrrolid and aminopyrrolid. The other stuff seems to be breaking down. We haven't tested for everything, but we've tested for a lot of stuff. And I'll help a little bit with go a little bit further into the chlorpyrrolid and aminopyrrolid. In Vermont, I know I'm talking to a Northeast audience. In Vermont, we had an aminopyrrolid problem about 5 years ago, I think it was. And that came in from horse hay. We have, in the Northeast, for the most part, we have outlawed or banned that particular chemical because it's so robust that it can be sprayed on a hay crop, it can go through the cow's body, it can be defecated, composted, and it still will kill broadleaf plants. Okay, so that's a problematic chemical. So the regulators in the Northeast said, okay, this one's it's too strong, we can't be using this.
Right.
So we were smart enough, but we do end up with it in the Northeast in our composts because we import hay. If we have a bad hay year, we may be getting hay from the Midwest, and a lot of other states do use chlorpyrrolid because it does grow things well. Now, if I'm making that and I'm using it on the roadside where I want to grow grass anyway, that's a perfect use for it. So the chlorpyrrolid won't kill the grass. It will just kill the broadleaf plants. If I was trying to vegetate with pollinator species plants, then I would be in trouble. It would kill all of the seed that I put in. They would emerge and then they would go. They would.
Oh. Well, so earlier when you were talking about Governor's Island and you showed us the tables and you made a comment about, well, I don't expect you guys to test for all this stuff. So what should a highway superintendent test for? So what's sort of the minimum list that they need to be testing for before they use a product?
Generally, you should be able to ask for an analysis. If you're going to be purchasing all of that, you're going to ask for analysis. And the things that you want to look at, now, so they'll do whatever analysis they think they want to. But if you know that there could be a problem with something and you want to rule it out, like is there any aminopyrrolid or chlorpyrrolid in this compost, then you would need to ask them to be able to do that. But a lot of the large compost facilities will do some analysis. They do some regular analysis, and you're able to. Biosolids compost is which is human manure compost, is tested on a regular basis. So that has to pass rulings. The other composts, most of the other composts don't have to pass that much stuff. So they don't have required testing, except that food waste now there's a little bit more scrutiny on food waste compost in a lot of states. The things that you do want to look for are salts, pH. As far as heavy metals or anything like that, it's on the roadside. And if it's being reused on the roadside, it's on the roadside, and it's not going to be a problem. So even if I were vegetating a ditch and I had a compost that had some arsenic or some lead or something like that, and it had a heavy metal in it affiliated with it, that isn't going to run off. The heavy metals don't go very far. They don't tend to leach at all, and they'll only move, they don't move in the soil. The problem with the heavy metals is if I were using it year after year after year, it would accumulate in that top 12 inches of soil, and I could have a problem with phytotoxicity.
So how does this relate to, on your map of New York, you said that there were so many municipal composting programs, and I'm going to guess that they were primarily leaf and yard waste. So here I am, my town does that, and I think, great, I've got all this compost, I'm going to go stick it on the roadway. Do you expect a municipal program to test before they do that?
For leaf and yard waste, so yeah, as far as testing goes for leaf and yard waste and even some of the manure waste and stuff like that, we don't generally do that much testing because we've done so many tests of those. Human waste is very variable.
Yeah.
We flush a lot of things. We eat a lot of different things. We have a lot of pathogens. We have a lot of metals. And that's why we're looking, because it's such a diverse waste stream that's coming together to form that waste stream. And that's why we would have more heavy metal problems with a biosolids compost versus a leaf and yard waste or any of the others. Now, leaf and yard waste can have low levels of lead in it. And that's because we used leaded gasoline for so long, for so many years, and it's been outlawed for many years, but we still have residual lead on our roadsides. We have lead deposition on our, on the roadsides from the leaded gas, but also from the leaded paints that were used on the gas, on the roads. So you have the striping and everything. They used to use all lead-based paints. So any of those little tiny crumbs, that can be a piece of lead.
Oh, well, that's depressing. Okay.
So if you're a municipality, if your municipality scoops their leaves up, you get less of it. If you vacuum your leaves up, you get more of it. Because
you mean like a curbside
collection
program?
Mm-hmm.
Yep. Okay. Wow.
Yep.
So you started talking about human waste, and there's been a couple of questions about anaerobic digestion and their appropriate use in these sorts of applications. And so I think you probably covered the manure part of anaerobic digestion. What about food in anaerobic digestion? Is the byproduct from that suitable for these uses?
There wouldn't be any problem with that. It'll digest down to a certain extent. You will have a higher, so if you're just using a digestate, so if it's going to be something that probably was dewatered, if you have a digester, it's liquid. Generally, most of them are liquid. So you have this liquid slurry, and that has to be pressed or dewatered so that you have solids, and then the liquids go into sewage treatment or whatever, or they irrigate fields, or it depends on the system, on what your goal is.
Okay, great. Now you mentioned salts.
But they could be used, but they're also quite immature. They're not a compost, so you can have a lot of odor issues. If you just used a digestate on your roadsides, you would probably have a lot of odor. And maybe it doesn't matter. Maybe you can get it seeded down quickly enough. You'll also have still have pathogens associated with all of the digestate. It doesn't kill all the pathogens.
So I'm hearing that as don't do it.
There are places where it can be done. If you're going to directly incorporate your digestate, that will be fine. So if you're going to till it in,
into the compost,
you want to mix it in on the roadside into the soil.
Into the soil. Okay.
Then you would be able to do that, but you may still have some odor issues. One of the reasons we use digesters is to fix that odor issue, but the solids still can have an odor to them.
Okay. Now, previously you mentioned let's test for salts. So what is the maximum salt tolerance that you think is acceptable? Salt limit that you think is acceptable?
You want to be at 2, 3, 4 millimoles. So you're going to, different people test it different ways. Yeah, maximum. If you're going to incorporate it into the soil, again, you can get away with a higher salt content. If you're going to put it on top of it, then you have to wait until that salt leaches out, and then you'll be able to grow stuff on it.
Okay.
So salt is, as we know, salt leaches into things and out of things.
Right.
Yeah.
So do you expect that when you use compost for erosion control, that it only needs to be applied once? Or is it something that has to be repeated?
Oh, I would want to be doing it once. It's not something, you may have to do a second application if you have, sometimes you're going to have a very steep slope and you might have a blowout like you saw in the slides where they did something wrong.
Yeah.
But you still could have a little if you have a deluge of rain, you could have some rivulets. And what I've done with situations like that is go and do another application. And I'll show you how we're doing the applications in some of the subsequent slides that we get to.
Okay. Well, great. Let me just ask then, I think, one more question right now. So are there examples of food scrap composting on roadsides? Not doing the composting on the roadside, but using it.
Definitely. It's no different than anything else, really. You could use food scrap compost, and if you're using food scrap compost, if you're using composting food, you're going to be mixing that food with something else. It doesn't just get composted on its own. It has to be composted with a carbonaceous material like wood chips or leaves or something else. Right. So you're never getting straight straight food waste.
Okay. Okay, great. So why don't we, if you don't mind, Jean, let's move on. There's a few questions that people have asked that I didn't ask, but I think maybe we'll come back to them. So that was great. Thank you.
You bet. Okay. And so I'm at this picture where they've planted the grass. I think one of the reasons that they were able to actually plant that grass or hydroseed that grass and make it successful is that they did use a track machine and press that all down with that heavy piece of equipment. And which I would have, usually we think tilling will make things grow better, but with grass, it does tend to grow better when it has nooks and crannies that it can fall into, and it's pressed down. Thanks.
You're advancing the slide.
I'm trying.
Oh, okay. I thought you were like
I'm
talking
trying,
to me.
Hold on. No, it just wasn't going. So let me try. There. Okay. Let me move. Can you guys see the panel in there? You're not seeing the panel. Good. Okay.
Yeah.
So this is a slope where we're putting a blanket down, and this was done in 2002 in Texas. And this was done with biosolids. They needed to vegetate this slope so that they wouldn't have severe erosion. And they were having a lot of trouble in Texas with their aquifers because they had a lot of bare slopes. And the water, the soil, the water, everything was, when they did get rain, was just flowing in and washing all the crap into the water supply. And so they, in a big way, used a lot of, they're probably, I would say, our leaders. They used a lot of compost, and they did use mostly biosolids compost in all of the slides that I'm going to show you here. This was a 1-to-1 slope. It was rocky. They were able to use, they needed big equipment to get this on, but there are different ways to do it. We do blow a lot of compost, so there's a blower truck that's filled with compost, and there's a hose coming out of it. I'll tell you what, it's pretty hard to get it up that slope, so I don't know if they were that successful in getting that up that easily, because I know sometimes you can clog when you're trying to go uphill that far. I probably would have put that hose up on the cross piece there and let it go from there, because it can be hard. You can clog your hoses, and when you clog those hoses, it's really a nightmare. But anyway, so they're blowing that blanket on, and this is not advancing consistently, so sorry. 8 months later, this is what they had. And there's a lot of mineral soil. There wasn't a lot of organic matter in these soils. So things weren't working. And, our whole idea with roadsides is not to have the tallest vegetation on our roadsides. So what they did was they put in native grasses and low mowing, no mowing, some of the lower stuff that would be able to survive in this situation. Our goal, I think everybody would agree with me, probably if they're working on roadsides, that is not our goal, is to grow a lot of vegetation and to block the roadsides. We just want to hold our slopes, and having good vegetative plants and interseeding with some of the, like this slope is not going to be mowed, interseeding with the wildflower mixes and things like that that are native to Texas is really helpful. Hold on. So this is the roadsides, as I said, were really, nothing was there. They were having a lot of problems. So this happened. This is a picture without compost. And that's after they applied and seeded. They did use some fencing in here to keep things in order so they could keep everything going, but they put down compost blankets there. And they're looking at an inch to 2 inches of compost that they can put down on those roadsides. And that compost ends up working its way down into the soil, the organic matter into the soil, and creates those blankets that we need. If there's no food in the soil, the earthworms can't do anything, can't do very much, and the organic matter is what they're looking for. And the microbes that live on the organic matter is really what they're looking for. So they can really till our soils for us and do a lot of incorporation of that material in these soil systems. This was a dump. I'm sure everybody's has these situations municipally, but this was a dump that was on Route 87, the Northway, in New York State, and they decided that they needed to restore it. It's actually in the meridian, in the roads, and they needed to restore it. It has almost no access to anyone, but they pulled the garbage out of there. They took the dumped areas, excavated that, and then we needed to look for the proper materials that could be used in this situation. So I got a call from our DEC, a personal landscape architect in DEC, that said, we have to restore this stuff. And she said, well, we want to use, there's a place near it that has some poultry manure. And we want to use that to create this. This is to create a bog situation so that the bog plants are going to be growing in there again. And I said, yeah, that's not going to work. So we need to find a higher organic matter, lower nutrient compost to put in here. And they were mixing different materials, different soil materials in this to make that mix proper. But if they had put in the nutrient-rich poultry manure in this particular situation, that would have been a problem. The poultry manure does a great job growing our vegetables, but it would not do a great job in this type of a soil system. So it's what we wouldn't want to do there. But this, I've never actually seen this. Somebody took the pictures for me because you can't access this one. I just advised some of the stuff, but this is what that area looks like now, or not now, but 2 years ago, looks like. And the bog plants are starting to come in, and everything is in much better shape. And there are always going to be reasons why we're doing those types of restorations. So, compost socks. These are the tubes. Sock material. It's generally a synthetic material, but these are tubes of material that are filled, and then we use them. This is the blower truck. There are a lot of smaller blower trucks. I think I may have some slides of some smaller blower trucks, but the big blower trucks do some pretty hefty work. So if you need something like this, or somebody has the ability to provide this, it's always a good thing. It's like a reverse vacuum truck. There are all different types and sizes of carbon, and when we're filling those socks, we may be using a straw, we may be using wood chips, we may be using a tub grinding. So there's a tub grinding down here that's on the lower right side. we may have a fine material. The fine materials are going to be pretty rough. So you can have a fine compost, but it may be too fine to go into some of these socks. Number one, it's going to be heavier. And number two, it may not do the filtering that we want it to do. If I use the next carbon here, so if I'm using this sort of a shavings, that might work, but it also, again, it's going to be heavy and it's going to have a lot of fines in it. So that can be problematic. So those two are not they're not used in most situations. Sometimes we'll use the fine material, sometimes we'll use the next step up. The coarse materials are what we would use generally in the ditches, because what we're trying to do in the ditches is to slow that water down. So if I have a ditch that's been scooped out, there's nothing growing in it at this point, I've got to keep that soil out of the stream, and I want it to get vegetated as quickly as possible. So I want to use this coarse carbon here, and the coarse carbon up here, a 2-inch municipal wood chip, it's what most places produce. I want to use that, and I want to put that into the socks probably. If I tried, I could use a coarser material. But what happens with these very coarse tub grindings is sticks will get stuck in the hoses, and then you'll have bridging, and then it's really hard to clean them out. So we tend to use the coarse carbon more, and the fine or compost if we're trying to do something with a finer material. And I'll talk about what's in each of these socks. This is a compost blanket that we're putting in, and it was an area that the water came over the road and washed everything out, and so we needed to get vegetation so that the culverts, the bridge would not get washed out. So we were putting in a good thick blanket in here so that the water could ride over things and not take all the soil out. You can see down here we put some large rock material in here, and some of these I'm doing with Soil and Water Conservation District in Tompkins County, because they had a grant to do some of this and to experiment and demonstrate how these things were working, and if they would work or not. So this has a lot of riprap to slow, and the water will be in front of that. And then in front of that, after we put the blanket down, seeded that, then we put the socks in there so that we would keep everything, we would be able to filter anything that was coming down in that little depression. Really important to put some kind of protection around our water system so that all the soil and particulate matter doesn't end up in our sewage treatment systems, because that's not really helpful. It clogs things, and it's better to keep things flowing better. So we use the socks to ring those and keep things out. And you'll see a bunch more of these pictures where, construction's being done. We needed to put in some good socks. There was a drainage area that was going out of there that will eventually be seeded, but while the construction was going on, wouldn't be seeded. And these socks were put in place so that they could retain some of that sediment behind, and the sediment will build up behind and get these socks in particular would be removed, but some socks we don't really need to remove, and as we go through I'll show you some of the situations where I wouldn't bother removing the socks until and unless the ditch needed to be scooped out again. Again, protect those drainage areas so that seed and everything else isn't getting down in there, and the particulate matter is not getting in there. But I mean, most of these things we see us doing, we do anyway. But I did take this picture because I had somebody that was applying compost, and they put the organic material. They put the pile of compost right by the drain because then they would be able to wash it away after they took the majority of it away. And I said, no, 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 no. We can't do that because we don't want to get that particulate matter into the sewage systems or into the water systems because it just clogs things up and we've got to go down there and dig them out more often. So it was something that I had experienced that I thought, oh, we should pass that on. Tree establishment.
So, Jean, let me interrupt for a second. Is there equipment available other than the mulch blowers to fill the socks?
There is. There are trailers that you can use to pull behinds that you can use to blow the socks. You go through. One of the problems that we ran into was we couldn't keep enough compost with us because when we had a trailer, and I was using a trailer, let me just see if hold on. There's a trailer right there. So this is a truck. So there's a truck there that we're shoveling it into this hopper, and then that is the hose is taking it out, and we're blowing it out into the blanket. So this is a pretty small blower, and as a result, you couldn't carry as much compost with you. Generally, you would be able to take a loader and dump it into that, and we did. We filled up the hopper as much as we could, but we just couldn't put that much into that hopper to do that. So there are all different sizes of equipment with all different costs.
That's great. Thank you.
Other questions? Okay.
I think you can keep moving.
Let me jump back. Okay. So tree establishment. So street trees and the like, landscaping in general. This was an experiment that was done to see what was needed, how much compost or lack of compost would be needed in tree establishment. This is 3 years of maple trees without amendment, and right next to it, that's 3 years of maple trees with amendment. So and I'll go back and forth for you. Tremendous difference. We see a tremendous difference. And one of the things that we're doing is actually backfilling like 50%. When you're digging the hole, we're backfilling 50% compost in that hole. So the tree isn't having any negative effects. In fact, it's having really positive effects because you're getting that tree established much more quickly with that. And I'll just run through those one more time for you. So that's without, and that's with. One of the things that we did a survey years ago at one of the Northeast shows of landscapers and DOTs and people that would be planting trees. And one of the things that they told us was that we don't want it in bulk. We don't want the compost in bulk. We want a 20 to 30 pound bag of compost because when we're putting 100 trees in, we're going to drop a tree and drop a bag of compost, and then we can just keep moving right through the system. And I thought that was interesting. I think it was 15, 16 years ago that we did some of that asking. And that's what we had found because we thought, oh, of course they want it in bulk. But you can't drive the truck down and dump a little here and dump a little there and dump a little there on a highway. So this actually ended up being a good strategy for getting the compost to the tree and having success with that tree. This was on New York State Thruway, and these didn't have compost put in the holes. And there was a lot of browning, and sometimes we get that from our salt and stuff, but these were too new it wasn't a salt effect. It was really a lack of nutrient effect. And just giving them that boost in the beginning is really helpful. Another, planting a tree. landscaping. So anybody that has been on the Cornell campus at all of our landscaping pretty much happens this way. It becomes a class project, and the landscaping groups actually take it on. The teacher takes it on, and they figure these things out. And this one is smallish gardens behind. And as we know, when we're working against buildings, a lot of times garbage is put back in as fill. So it might be crumbs of rock and concrete and all kinds of stuff. So and the compaction around building something is tremendous. So what was done with this was the soil was actually taken out and then mixed 50-50 with composts. And in this particular case, we were doing research on dairy and poultry, and to see if there was differences in the dairy and poultry composts being used here. And it ended up being, they both looked really good. So we didn't have a problem with either, but we put 50% soil, 50% compost, 50% soil in those situations, and the gardens propagated tremendously. They did. It was a really nice showing. So, and these gardens, this is 10 years ago, I think. So these gardens are good. And the other thing about the way that the compost was incorporated here, when we're putting in gardens and city plantings and things like that, we are still getting a positive organic matter result from this. We don't have to add anything at all. So we're getting good nutrients transfer. It has created a sustainable system for the plants that are here. So that's a really nice thing to be able to say, is I don't have to do a lot of weeding. I don't have to do a lot of work. I've got what I need here, and my plants are growing. This is a Homer compost facility, and they put in a garden alongside their compost just to show people how it works, and it certainly does. So this is a compost blanket that's going in, and it's over a stream. It's about 15 feet down to the stream, and both sides of the road were cleared of vegetation. So they went in and they just took everything out. And then this was about early October that happened. And trees, everything. And this is a very protected stream underneath, very clear trout stream, whatever. But it needs to be protected. So we went in and we started working on covering the bare soil. And can you see my pointer when I'm moving it? I'm hoping.
Yeah.
Okay. So what we did was we put blanket material in here. So we sprayed all that in here and then hydroseeded this portion. We also put the socks in right below the guardrail. And the guardrail was, the road is obviously right on the other side, and the road was set so that all the garbage, all the salt and the sand and everything just comes right over that bank and right into that area. So we pinned the sock in there. We pinned the sock down below so we could catch anything that went under that sock, and to start working on that. This was a little bit farther, and remember I said sometimes we need to put a little bit more application in. We had some blowouts go underneath these rails, underneath the socks, and really just create a rivulet. There were only two, and that was a long stretch of highway, but anyway, we went back in and we put more in the spring so that we could fill those and get that vegetation established. As we're going, sorry, that broke up. You can see we've even hydroseeded over the sock, because the grass will grow right out of it, and it creates even a better system. And then we have all of the grass starting to establish, and then we just worked on those rivulets. But we have the lower sock here right above that wall that has caught. You can see there's more material right behind that sock. So that's really filled that in there, and the vegetation will take over and do the rest, so that we won't have any more soil going into the stream. In these situations, I would not remove the socks in that one, because number one, that's a precarious place and it would be hard to get it out. And this one will it will be helpful to keep all of the riprap all the garbage that comes off the roads, oil, gasoline, anything that washes off, keep that up right on the roadside and not down into the stream. This is what it looks like. That was about 8 months afterwards. And they put a clover, soil and water put in a beautiful red clover mix in here. And it is just, I don't have a good picture of that, but it is just gorgeous. And everything's low growing, so we don't have problems with visibility and all, but we did both sides of the road here. This was a culvert, or it is a culvert, where the landowner swore that there was never any water coming across the land here. But they had successfully grassed it in, and it was beautiful. It is beautiful grass, but the water does flow over that. And what was happening here is it kept cutting back and cutting back into the banks where it was just taking that lawn, and it was a vast lawn, so it wasn't that big a deal, but we still don't want the erosion, because all the stuff that's in the ditch down here is going to wash down into whatever stream or whatever waterway. So what we did was we shored up that side of the grass, and it goes down further as we go. But we take the socks, and we did 2 layers in here, because I could see the grass roots were hanging down there, and they were getting plenty of water, so they were happy. But the grass roots were down there, so we put the socks in there to keep it from cutting back. And then this will just be mowed. The homeowner mows that anyway, and we can use it that way. We pin these in because the water does flow in a lot of these ditches, as most people realize every once in a while. So,
Jean, I've got a couple of sock-specific questions. I'll ask them both. Are there any socks that can decompose over time for appropriate applications? And the flip side of that, do socks need to be replaced over time?
Right. So there are some degradable socks. I have not worked with any of the degradables, partly because sometimes these socks are filled and then they're left to sit, and they would start degrading too quickly, I'm afraid. But I don't have experience with them. I think they would be beneficial in a lot of places. But the sock does add a lot more rigidity, and I don't like having any more plastic in the environment than we already have. But the rigidity in the erosion control applications, I think in some cases, I would just assume have them there. Some of them are taken out and reused, so we can just move them to another place where we need to. These will not be. The grass will grow over those and we won't see them. But we put in pretty long stakes in there, and then we cut them off with a sawzall, just so that we have them pinned in there well. I think that probably answers the question, and I'm not answering it well for the degradable, because, and I'll show you some places where I might consider having a degradable, but I think what would happen is we would end up scooping those places out anyway, and some of these socks are in place for a couple of years, and we'd like them to function the way they are for a couple of years.
So when you reuse them, do you refill them?
Nope. No, we would take the socks just that way and move it not very far because they are pretty heavy. They can be pretty heavy things.
Great, thanks.
Mm-hmm. This is another culvert, an undercut bank, and the water is going under the pipe is right there, so the water's going under the road there. But it was, hold on, there. It was undercutting, so we put the socks up in there, and the rocks don't mean anything. They were just, I was getting them out of the way. So the socks are in there. They're pinned into the bank well, and make sure we were using 4 or 5 foot stakes, and we'd pound them in as far as we could and then cut them off. There's water coming in here from a tile. So there's a lot of action happening here. So, and this was going back, and there was some kind of a electric pole, something up in here that we were trying to, not allow the ground to lose more ground there. This was 4 months later, and that will keep filling in there. It won't be able to erode away. And those socks, you can see one, I think you can see one stake here, if I can find you. One stake right there. But in general, those socks, they will disintegrate or degrade eventually. And we really can't see that after only 4 months. So that's something that should stay in place, because when we get deluges of rains, 2-4 inch, rain events, that's when those things are really tested, and those socks are going to help keep that where we want it to be. Does that take care of that?
Yes, it did. Yeah. Thank you.
Good. Okay. Socks in road ditches. So this is a very steep road, and they did the ditch cleaning, and maybe a little bit too aggressively, because it goes all the way up right to near the tree roots and everything. So we really want to keep all of that in place, because those roots are really important for keeping that culvert there and not just washing out that whole area. We pin the socks. These have coarse wood chips in them. We put those in, pinned them in, and as I said, they're a little bit heavy, probably 40 pounds for a 6-foot sock. But they will stay in place, but it's amazing how easily the water can move them if we don't pin them in place. So the next slide, you can see not very well, but you can see the sock is in place here. All of the soil has filled in behind that sock. Some of this might need to be cleared out so that we don't overrun them. So this may have been, generally they'll make some stair steps. They'll create like steps. So it slows the water down as we go down the steps. And that's what we were working on. So we have the socks in those really steep areas every 10 to 12 feet, and pin those in and try to create those flat areas so that the water slows down and doesn't just take everything down and create deep pools. There's another sock in here. You can see that's, definitely holding things back. This culvert was actually going into a class 1 stream toward the bottom. It's just the way it was shaped. So this is the area that comes into the stream. It was impossible to keep the culvert going that way. The culvert decided it was going down this way. So we put an extra large sock in there, and then we did put a second sock in afterwards, because it really needed to create a dam, but we don't want it to be too much of a dam. We want the water to be able to flow through it, and that's the reason that we have the large chips in there, is because those large chips, eventually that filter will clog up, but we'll be able to get a lot of material through there that caught in that sock and be able to use that. And that's one that I would probably consider, if it fails, when it fails, it would definitely need to be replaced, that particular one. All the other ones are up above it, and that one's in place there and is holding nicely, actually. I check it periodically. This is a state park where, so we can see the waterfall is coming here, and it looks like a mellow sunny summer day, so that's not a problem. But the water was coming down into here, and it was cutting all the way back in here, and it was dropping down this way and removing parts of the park. And we can say, okay, we shouldn't change that. But it's a result of dams that were put in a long time ago, and other water devices that were put in, water control devices that were put in a long time ago. So they're trying to bring it back to its natural state. So in this hole back here, we ended up, so the rock comes over here, and the hole back there, we've got a dozen hefty socks pinned into there, so that it will, some of the branches and some of the brush and everything will collect in those and will actually create more land. So we took the socks, so there are some jammed vertically up in this area, and then the water was coming all the way up into this area, so we put some more socks in here to slow things down, to hold the bank. We have some low socks here, and another one over there. There's some under here to slow things and to hold that bank. And then we put in native vegetation. So the park people came in and put native vegetation. You can see we also put some native grasses in here. Those are not growing yet, but what we used in some of this is what they call quick sticks. So a willow cutting that you can just stab into the ground because there's enough moisture and everything, and they'll root themselves. And that, so the dogwood, the willow, a couple of other things were put in there to create that barrier to hold the soil and to hold that whole bank after a while. There was also a drain coming off the parking lot going into that stream. This is Upper Buttermilk Falls, if anybody's familiar with it. But all the crap was coming off the parking lot, and there was a lot. So what we did was we created we added some compost to the sides. We put some socks in here in a couple of places, and we seeded that whole thing down so we'd have a grass swale with filters going down into that stream. So here we were doing some of the research that I mentioned with the 1/2 inch, 1/4 inch stuff many years back. We were looking at playing fields, parks, and we wanted to look at how compost would work. And again, we were working with dairy and poultry manure composts in this situation. One of the things that we found was that the phosphorus was a little bit high, but since these were flat fields, there wasn't any ability for it to run. So we could use that higher phosphorus and a little bit higher nitrogen. The grass green up was amazing on these, but what we did was we took these plots, put 1/2 inch, 1/4 inch, we did some fertilizing and tried to recover some of these playing fields. You can see this is a football field, is a football field, and we were just trying to get the grass established on it again, and more durable and more sustainable. So put that in there. You can see just by the time we're leaving, this is what things look like. We rake it in. And in some situations, you're going to have large equipment to do this, but there is that equipment to do that. There's manure spreaders. There are our rakes and stuff like that you can do this with. But we actually had, when we were working on the soccer fields and the football fields, we had people playing on them just days later. So it was pretty fast turnaround for those. I have another one. Really early, this wasn't the picture, but really early spring green up. So we're getting that grass growing very quickly. This was an area actually on the Cornell campus that always bothered me because it had such lousy grass, and we're an ag school. We should be able to grow grass. We should be able to grow, plants and stuff like that. So, and this is right on one of the main roads on campus. So what we did was the landscaping department said, yeah, let's try to get this improved. So we actually just put a blanket on. And what we do when we're putting these blankets on, and even with the soccer fields, we used a core aerator, which takes these long plugs out of the ground, the soil plugs. And so we core aerate, then we apply the compost. The compost can filter down into that soil, and we're able to get better results more quickly. In this situation, we used a different tool, more like a tiller. So the grass is down there, we put compost on top, then we used the tiller before and after, and that was able to incorporate material in to the soil so that the plants and the plant roots, they decided that they didn't want to seed this. So they didn't use any extra seed. Sometimes we would use seed, but for the most part, we're not adding more seed. We're just trying to get the grass growing that's there. And this is actually very beautiful. This was just the next, couple of weeks, or probably a month and a half later. The grass is coming through well. It's obviously fall. Now it's really beautiful, and we still haven't seeded it. Seed can be expensive. So if we don't have to, if we can use the grass's natural root systems to spread, this compost application allowed that to happen, and we didn't end up adding any grass seed to this. Okay.
That's terrific, Jean. We only have just a couple of minutes, and of course, the questions continue to flow in. So I'm just going to pick go back so we can see
and
your
that's
contact
my
information.
Last slide.
Okay, yeah. Okay, so just quick. Would Compost Socks work on agricultural fields to stop nitrate runoff, sort of like a biofilter?
Absolutely.
Good
answer. We use so DOT will often use, and in Massachusetts I've seen it a lot, they'll use hay bales to slow things down.
Yeah.
The Compost Socks work just as well, and we will even just put a berm down. So if we put a compost berm down, that will also filter it, and then we don't need the sock. Huh. So we would just put a berm down, and then we're not adding the plastic there, and it will just stay in place, and it will filter the water as it goes through.
Great. So a couple of people commented, variations on a theme, that there are non-plastic socks, jute and 50-50 blend. I imagine you know that, but just to share it with the group. And somebody asked, would a 50-50 blend of leaf compost and wood chips be useful in a sock? What would be the challenges?
I don't think I would do, well, if you ground the leaves, it would be okay, but they're going to become compost more quickly. Mm-hmm. So if you want them to act like wood chips, if you just put the wood chips in, they'll act like wood chips and they'll filter longer. If you put the ground leaves in there, also it would break down more quickly. Okay, great. The same with straw and Excelsior, and I've seen a lot of different things. And I think one of the reasons people are using some of the lighter weight materials is because it's easier to haul some of the things. But those socks I haven't seen very many that have stayed in place very well.
Okay, great. So let's have this, well, you don't know what it is, but last question. I'm pretty sure the question came in when you were showing the flat field test just a few slides back, that you, what type of compost was used in this test?
What type of compost? In the flat field was dairy and the playing field?
Yeah.
Or the Cornell one?
I suspect Cornell. It was like 4 slides back.
The roadside one, yeah. The main road through campus, that one is that we were using a very varied mix. So that one has everything in it.
Not even easy to
manures. Yeah, it has manures. It has, and you can name any manure, and it'll probably be in there because it's vet school. So it's a campus manure. It's got food waste, but actually, we only have like 6% food waste in our whole compost. Wow. We have about 4 acres of compost.
Incredible.
So we have a lot of animal waste and a lot of,
Great. Well, Jean, thank you so very much. That was sensational. And thank you to the audience. Great questions. The slides will be available on the NERC and NMOA websites. We will be posting the recording as well, and everybody will get links to that information. And Jean, thank you so very, very much. Wonderful information, and I'll say good afternoon and best wishes to everybody. Thank you.
You are welcome. Thanks.
Take care. Bye-bye.
Thank you.